Hello everyone. Thanks for joining Prague DevOps Meetup, even though it's online still. We'll give a few more minutes for others to join, so just hang on. We'll start in a few minutes. Okay, so welcome again. Thanks for joining. Please keep your microphones and cameras off just to make sure there is enough bandwidth and that we can hear the speakers. If you have any questions during the presentations, please put them in the chat, or of course there'll be space at the end of the presentation to raise your questions in person and speak up. Then feel free to turn on your camera as well if you want, or don't, up to you. And yeah, let's open for discussion, of course, right? So today we have two topics. The first one is from Maria. She'll speak about like DevOps cookbook and how we can not necessarily we, but how the DevOps teams can talk to devs. And then we have Jan, who will talk about their pull request review apps in Kubernetes. So I'll hand over to Maria first, and yeah, enjoy and have fun.
Hello, everyone. I hope you can hear me well. I'm going to share my presentation just in 1 second. Let me know if you can see my presentation.
Yeah, I can see it. All good.
Great. So yeah, we're going to talk about DevOps cookbook, basically how to build a smooth process with your development team. My name is Maria. I work as a DevOps engineer at Citrix. And what we have for today, I'm gonna talk a bit about DevOps role in a project lifecycle, how to set and achievable goals, how to audit your application, and what actually I can have in my I have in my tool set to make developers' life a bit easier. So let's start from DevOps role in a project lifecycle. Basically, as a DevOps engineer, you can join the project at any stage. It will be the perfect case when you can join at the early stage. Then you can impact the process. You can help with CI/CD pipelines and etc. But usually, our help required only on deployment or maintenance step. And honestly, during my career as a DevOps engineer, I often faced a very challenging projects when you need to, for example, migrate the whole application to the brand new environment. And it was some cases when you don't have any developers in your team, or project will be on hold during some uncertain time, and you need to gather as much information as you can while developers are still here, are still willing to help. That's why I want to tell you more about interaction between DevOps engineers and development team, and how you can actually perform an audit for some project as well. So regarding achievable goals, I suggest you before, let's say, before doing any task, just try to plan your work. And if you set goals like realistic, if you collaborate with developers and you ask what the problems they have at the moment. So for example, it could be anything from a lot of rolled back releases to just lack of core development processes, with Kubernetes. You can try to use smart approach. I personally would suggest it because it allows you to specify the target goal. You can just answer simple questions: what actually you want to do, how will you know when your goal is successfully accomplished, right? If you can do it alone or you need some external support. And the most important, when exactly do you want to accomplish it? So you should be time specific. Just define how many time you need to achieve some goals. And I prepared some good and bad examples regarding this. So I often see some tasks like audit the project, configure deployment, configure monitoring. And it's okay to have tasks like this, but when you have really tight interaction with development team, you should be more specific, because they need to understand the target goal. What are you actually wanna get at the end? So for example, if you wanna just audit the project, you can't measure this task. You can't say what the final result will be. And it's better to rephrase this goal to something more specific, like solve 5 most critical problems in the infrastructure of Service X. And this description will help managers, team leaders, your teammates to understand more specifically what you're trying to do, how to measure it, because you have some like defined points, right? You have 5 most critical problems and you wanna fix them in the infrastructure. And of course, audit the project can be the part of some goals. It's okay, but in this project, you can specify uh, the part that you want to audit. Or maybe you want to work with documentation, maybe you want to work with monitoring stuff, or maybe with infrastructure. Then you can be more specific with estimations, with final result, and etc. Regarding configure deployment to new AWS region, it seems to be okay. But for example, if you want to take a vacation, or you will be reassigned to another project, one of your teammates should like take care of this activity. And if your teammate will have description like that, it can be a bit obscure, and it will really hard to understand what is going on here. So if you rephrase it to more specific configure deployment for all components of Service X to Kubernetes in AWS U West 1 region, your teammate will have like certain points that can allow to estimate this activity, to break it down to some smaller steps, smaller tasks, and it will be much easier to start working on this activity. And the last one, configure monitoring for Service X, is also okay, but it's not very clear what actually should be done in scope of this task, because I can deploy the whole Prometheus stack, or I can just configure some small parameters in the application configuration, right? So it will be really difficult to estimate this task if you don't know what exactly should be done in scope of this task. And it can be rephrased to be more certain. So if you actually need to deploy Prometheus, it's better to specify it in the task. For example, maybe you need to deploy Prometheus but not Grafana, and etc. You can just write it down, and you can specify the environment for which you need to accomplish this, or for all environments, for example, because for sandbox environment it can be easier than for production, and you need to spend more time for this exact activity. Also, I want to emphasize that in every example, we have a time period when this activity should be accomplished. So we have quarters, or we have sprints, and it can be more clear for like external people like managers or team leaders to prepare, some high level overview of what team is doing right now, what is their focus, and it's just better communication at the management level. So this is just an examples. During my presentations, there are a bunch of links, and you can explore it. I think after the meetup, I will share the presentation. So if you are interested in some topic, you can follow the links and learn more. And regarding audit of application, I want to say that it can be really hard to review the whole service, the whole bunch of microservices, especially if there are a lot of a lot of components with really tight integration with some external services. But you should be pretty sure about your goals, and if you understand that you need to improve like monitoring and login stuff, try to focus on this part, and do not try to do everything. If you see some bad configurations in a Docker file or Kubernetes manifests, you can create a technical debt, but you shouldn't like try to solve them all at one time. Try to be more focused on what's currently important for the developers and for the processes, and try not to solve everything. So starting from audit, I want to emphasize the importance of documentation. And when you review documentation, you should be again pretty sure about what the goal you want to achieve. And I suggest you to focus on goal to have enough documentation to be able effectively support or hand over a project. And in this case, you will try to have enough documentation, right? So you can support your application, you can deploy it, you can somehow debug it, maybe with developers' help, but it's like a constant process of improving docs, and maybe it's better to have some, let's say, mm, some critical items, not all of them. I would suggest you to check if your service, your project has an architecture diagram with just main components and interactions between them. It's better to have this like picture, because with this you can actually gather some minimum required information to start actually working. Also, usually documentation contains a list of external dependencies. So, for example, if you use some cloud services like S3 buckets or some cloud managed databases, it's better to have these dependencies specified. Also, configuration management, if you have a bunch of environment variables, it will be useful to have them listed, maybe with some examples of their values, and like a short description why we actually need them. Local development procedure is very obvious. If development team has a new teammate, it will be easier for this person to actually start working on the project, on the real task, if we will have some start point, to point. Just say we have like this procedure described in the docs, you can check it. If you find some problems or misconfigurations, you can like try to ask, or maybe you can update the documentation as well. And also for DevOps engineers, it's important to have some ops documentation, like monitoring, logging, debugging, deployment, and all of this stuff. So it's just an example of what we can have in documentation. It's not required to have all of these items, but they can be really useful for some projects. How actually start talking about writing docs? Writing docs is very boring for most of the people, and you will be very lucky if someone from a development team loves writing docs. But actually, your role as a DevOps engineer usually initiate some processes, and if you see that some crucial parts are missing, try to initiate a process and try to lead this process, because you should explain why this specific item is important, and try to help in any way as you can. If you have some templates for docs, it will be a great start point, because sometimes you come to the project and there is no documentation at all, and it's will be easier for developers to start writing it when they have some template, or maybe even a good example, because they can understand why those items are valuable, and why they actually need them for their project as well. And also try to be specific as possible, not just please create me an architecture diagram. Try to emphasize that they should specify all of the components, maybe network interactions between components. Maybe they need to add some internal services that application uses all the time. And it will be important for them to understand all of the requirements, because they like will be happy to do this operation only once. And it's really important to like get the required result for you, because it's important for you to proceed with the project and learn more about components and how it works. The next part is a DevOps audit. It's more about processes and like integration of our application inside the company services with our customer and etc. So basically, you should check CI/CD pipelines, release process, how actually we bring new version of our service to the customers, how this new version is deploying right now, and what is the process when our customer has some problems on production. um, it means that we should all participants in this process should understand what are the actions, how the problem should be escalated, and what is the expected result, right? So it can be a task to the development team, or it can be separate support team, and this team will try to resolve problem first. So it can vary from company to company. At this point, also try to be focused, and our goal is to find bottlenecks in the current development process. Again, you shouldn't fix like all problems. You should try to understand what actually bothers developers, and maybe there are some problems with stability of CI/CD pipelines or etc. And you can mark it as a task to take into account right now, or you can also create some technical debt related to DevOps activities, and maybe you will have time to look through it at the end of your work on the project. So again, if you want to be successful as a DevOps engineer, you should communicate with developers a lot and ask them about their development process, how they deal with technical debt tasks, how they do the code review, and etc. etc. So if they have some problems, you should take care of it. Maybe you should try to investigate what is the root cause of some problems, and this audit can help you with it. Check all CI/CD pipelines. It's a common step. You should check maybe there are some missing steps for particular programming languages. Maybe they use some bad patterns, or you can bring new best practices, and it will increase stability and quality of the code. So you can just check all these files. And also you can check build and deployment configurations. It's very common problem when there is a lack of versioning for Docker images, for some packages, and etc. etc. And it can cause potential problems with deployment, with stability, with debugging, and so on. So that's it for DevOps audit part. It can be, of course, scaled to more steps, but I think it's the main one. Regarding infrastructure audit, it's a bit complicated because infrastructure is a huge topic, and in current realities, we have a lot of different approaches to infrastructure, and it's really depends from your specific case. But again, try to configure the right goal during your audit. Try to understand what actually you want to achieve, and I suggest you to concentrate on following goal when you're trying to check if infrastructure meets the requirements. It can be anything from reliability to high availability, and for each of these cases you will have different possible configurations and different approaches to verify if actually our infrastructure meets those requirements or not. You can start from checking technologies and tools that was used to provision this infrastructure. You can try to define what is the type of environment. Do we have only cloud, or we have only self-hosted environments, or we have hybrid infrastructure? So, for example, part of our services are in cloud, and another part, maybe it can be a legacy, it's in our self-hosted environment. And of course, in these cases, there are different approaches and steps that you can take. And the last one is the environment configuration. Of course, there are a lot of ways to provision environments, and you can check how actually they were provisioned. So it can be really various approaches. In some companies use only Ansible. In some companies, it can be only Terraform because they work with clouds only, or it can be another tool like Puppet, Chef, or something else. Of course, if you have some defined requirements, you can start from this point. But if you don't have, you can try to communicate with maybe managers or product owners, or maybe development team, and they will try to maybe specify, the one or two that you should definitely take care of. Also, it's important to check the process around config management tools. Sometimes the lack of process can bring a lot of problems. So if you don't have proper versioning code review for infrastructure related files, it will cause a lot of problems in the future, or it already does. So you should try to define if it can be really critical for you, or you can just again add those problems to the technical debt. Also, it's very common when those tools, those infrastructure services are like not very fresh version, right? It's like they were updated only once at the project start, and that's it. Of course, it can be a problem from security perspective, because usually there are a lot of tools that have a lot of security issues, and they of course fixes sometime, but in the future releases, and it's important to upgrade it in time. And also maybe you will need some new features, but you can't do it you can't upgrade right now. You need to understand if it worth it or not. And of course, it's not a whole list, but it's like some points that you can start with. Maybe you can add more and more, and it's great. But I was trying to create some basic list with steps. Maybe we can upgrade it a bit later when will be a new X tool that we need to take care of. So yeah, that's it from infrastructure perspective. And of course, we have security side, because we live in the world of web applications, and our web applications interact with users, and users want to be safe, want to save their data, their passwords, their emails, and etc. And for security perspective, our goal is to minimize security risk for environments and users. Of course, we can't reduce it to zero, but we can take some actions against again, like Docker files, Kubernetes manifest. We can verify if they if they contains required configuration against malicious software or not. We can use or manual checks or automatic checks. There are a lot of different tools. Also, we can check environment configuration. So, for example, do we have private Kubernetes clusters or not? Do we have configured firewall rules? It can be also important to have some overview of these settings. The next one is user permissions and roles. Maybe it's a good time to do a review. Maybe some users are exceed their permissions. Maybe you can optimize the roles that we've been using. And also very important, it's secret management. It's important to understand how secrets are managed for your service. Maybe for now it's just a plain text and you can easily move it to something more secure, especially if you have some company-wide solution. You can suggest to help with migration to this solution. I think developers will be glad to make their application more secure, because in the future they will have less problems with it. How actually you can perform the security audit? Just a simple steps, as I said, automatic checks or manual checks. It depends from the size of the project and from your let's say abilities at the time. Also, if you have a dedicated security team in the company, you can ask them to perform an audit. You can specify to which repositories or services look through in the first order. Maybe you have some guesses where they should start. And also a review of secrets management. It's also very important, because sometimes there are really crucial problems that can be solved with GitLab repo settings, for example. And the last one, from audit perspective, it's observability. It's very common that in a project this site is very poor, I would say, because it requires some expertise from developers to actually have a good monitoring and logging configuration, because it's not very easy to debug in general, and it's hard to define how actually you should debug your application. And at this point, goal can be something like that, like have all the sources to investigate any problem. And if you have like simple application and it's enough to have just logs, you can have just logs, because your application can be monitored by another solution. You can monitor just process, you can monitor disk usage, CPU usage, and etc. But if you have like complicated high load application, it's better to have some logs, some metrics and alerts for application in the first order. But it's also important to have metrics and alerts for infrastructure, CI/CD pipelines, security issues as well, because application is still running on the underlying infrastructure, and if something wrong with infrastructure, we should know about it, right? Because it can reflect on the application itself. How actually check if everything is fine or not? You can start from checking logs, its format, if everything is fine from this perspective. If it looks okay for you, or maybe you have some policy inside your company, you can validate those logs against this policy. After that, just try to search something related to the service in log aggregator, and if you see that it works fine, then it's fine. If you see that logs, for example, logs with exceptions or huge errors are divided into several log messages in Elasticsearch. It should be fixed because in the case of the problems, it will be really hard to debug the problem because you will have like thousands of lines and it will be useless in case of real production problem. Regarding monitoring, usually if application has some metrics, then it will have some dashboards in Grafana. If there is no monitoring, I think that there is no dashboards, and you can start from helping to define what metrics should be added to the application. And it's not that hard. If you have a web application, you can start from the count of requests, their duration, count of errors, count of users, and etc. And if you have some, I know, maybe queue service, you can just count number of events that are waiting, that are processed, and etc., and build a simple Grafana dashboard that developers can check in case of any like problems on production or any other environment. Also, it's important to check alerts if they cover critical problems, and you can take some actions for these alerts, because it's really common to have alerts that are not actionable, and you should help with like cleaning this up. Maybe if developers complaining about amount of alerts or that they are useless, you can just review those alerts, maybe add some new alerts, and it will clear the situation. For, let's say, for start point of application metrics, I added some links on the slide, so you can check it if you are interested. And the last step that I want to mention is that if you have like really huge number of microservices and there are a lot of problems with debugging their communication, and there are a lot of chains of requests between them. So for example, your application ask backend, backend ask another backend, and etc., and it can be really hard to debug the problems with those chains. You can try to integrate tracing. It will require additional code changes, but maybe result will be satisfying for you and for development team as well. Regarding toolset, of course, there are a lot of tools that can help you with automating all of these steps. For auditing, you can just run them locally, or you can directly integrate it to CI, so developers will see the feedback, right? They change something in a Docker file, and they will see that it brings new security issue at their application, or that they created something that against Dockerfile best practice, and it will impact, for example, Docker image size or something similar. So I will try to just briefly look through these tools. And regarding documentation, there is no much progress, but if you need to start with something, you can try to go with some README files in the source repository. But if you need something more, you can try to adopt Notion. If if it's not a very big company, you don't have some really huge tools like internal GitLab or GitHub or Confluence with Jira, you can try to use Notion for it. If it's okay, it has really nice UI. It has some features that allows you to organize everything in convenient pages. And I think it can be really nice solution for some not very large project. If you are trying to find something more interesting and you want to build company-wide solution for documentation, you can try to check Backstage that was developed in Spotify. Maybe it will work for you because it has really nice features, it has nice UI, and it's not that hard to write documentation because it's still connected with source repository, but you can see a nice visualization for it, and everyone in the company can check the documentation, interactions between several services, and etc. So maybe this solution will work for your case. Regarding deployment to Kubernetes, there are a lot of tools. I personally love to use Helm file for declarative deployments, especially for infrastructure related services. You can just define all of the Helm releases in one file and you're good to go. If you want to improve documentation for your Helm charts, you can try to use Helm Docs plugin. And if you want to have more visibility about changes that will be applied during chart deployment, you can try to use diff plugin for Helm as well. Regarding chart testing, there are not much really useful tools. You can give it a try for chart testing framework from Helm itself. It can allow you to verify your charts against some policies if they are well formatted, or they have owners specified in the chart documentation, etc. For smooth upgrade to new Kubernetes version, you can try to use kubewell. It's a very famous tool, or Pluto. They basically do the same, but kubewell validates manifests and Pluto detects deprecated API in some clusters. So it's like a bit different approach, but you can take advantage from any of this tool. Regarding infrastructure, I personally love testing framework for Ansible roles, Molecular. It's not that hard to get started with. They have some examples how to test roles, and if your infrastructure was built using Ansible, maybe this is perfect solution for you to test your huge, like very rich Ansible roles and be sure that your changes won't break anything. And regarding Terraform, there are a lot of different tools, and I love Terraform pre-commit hook because it includes all of the tools that I need, like Teflin, Tefsec, Terraform docs, and so on and so on. And you can use this hook before commit eventually, and also in CI. So it will help you to keep your Terraform files consistent across several repositories, and it's more it will speed up code review process as well. TevSwitch is a simple tool, just version management for Terraform. If you have a lot of Terraform repositories with the different Terraform versions, and you don't want to mess up with Terraform state, you can just use TevSwitch and it will work just fine for this specific case. Regarding containers, there are a lot of different tools, but I love to use Hedlint because it allows me to to check my Docker files in code editor in CI, and I can just scale this tool for every repository with Docker file, and it will work just fine. There are like more tools like that, and you can explore them if you want. It's not like only Hedlint and nothing more exists, but I think it's like really nice step in CI to have. Regarding security, I love to use Trivy because it's easily integrated into CI. You can just add scanning for Docker images, and you will see report at the same job, and it's easy to check, and maybe developers will let's say we'll check it once a week, once a month, once a quarter, and upgrade some base images and stuff. Also we can run Trivy for Git repositories or just file systems. So it's open source and it's easy to use. Maybe for your case it also will work just fine. Regarding analyzing Kubernetes clusters, so for example, you just come to the project and you will see Kubernetes cluster. You need to understand what is going on in this cluster. Several times I used Polaris, just deployed it and check via this UI what are the problems exists in the cluster. It just shows you misconfigurations, missing resources, root users in the manifest, and so on. So it's just a nice tool to start with when you see some Kubernetes cluster in the first time. And also similar tool, Kubebench. It's basically same as Polaris, but it has a bit different checks, and it can be useful if you have self-hosted Kubernetes cluster, because it can also scan kube API options as well, not just Kubernetes workload. For local development, I'm pretty sure if you use Kubernetes, you know about Minikube and Kind. It's very common tools, and I put it here because I personally use it every week, every day. But for local development, there are also two interesting tools, Scaffold and Telepresence. Scaffold is more about up and running application inside the Kubernetes cluster. So developer can just using one command build its application, push this builded image to registry, and deploy this application to Kubernetes and see logs from this application at the same time. So it's just an easy way to develop some stuff for Kubernetes. And telepresence, it's a bit different. This tools allows developers to forward traffic from the cluster to local machine, and it can do many more things. So if you or developer need to debug something inside the Kubernetes and you wanna receive some traffic from the cluster to your local machine, you can use telepresence, and you don't need to use kubectl command. You don't need to ask DevOps, right, to check what is going on. Developer can do it by themselves, and it will work fine. I think it's really useful and not very famous tool across the projects that I've been working on. That's it from my side. I just want to wish you happy sailing at the end, no matter where and how you will work with modern technologies, with some projects, Kubernetes, not Kubernetes, it doesn't matter. You can be a successful DevOps, write documentation, analyze some environments, and I don't know, make your developers happy at the end. So thank you again. If you have any questions, I will be glad to answer them.
There are some questions in the chat.
Okay, let me check it.
Yeah, so there was a question if you tried C4 model, which is supposed to be like specific approach to building docs around diagrams of a service. I think it was related to when we were talking about documentation.
No, I haven't tried it yet, but I will check in my free time. Maybe I find it useful. Thank you for asking.
Yeah, if anyone has a question, let's just please raise your hand so we don't jump over each other. So I'll use my word as I speak already, ask question myself. When we are talking about a security audit, like, do you have any tips how to include the security team early in the process and make sure that the interaction is actually working well instead of being like a fight between devs and security?
Um, Usually it's not the case. I actually don't know why, but a lot of development projects, was created just for proof of concept, and eventually it's in production, and a lot of users, use those projects every time, and no one from security team was reviewing the initial architecture or security perspective. And I think that maybe some required procedure that developers should pass, in the first order to actually publish their application to production can help. Just some list of the requirements, like this team should review your CI/CD pipelines. This team should review your code from security perspective, and maybe this will help because I worked at the company where this process like exists, and it was working. But it's important not to overwhelm developers with all of this stuff. So it's like less stuff they need to do, it's better for them and for all of the involved people. So I think it should be company-wide stuff like scanning source code repositories, scanning Docker images, and etc. So developers shouldn't be worrying about all of this stuff. I think that's it.
Okay, thank you. Sounds great. There is also a suggestion in the chat that Case 3D is a great tool for local development. You can create multiple Kubernetes clusters on your machine, and each node will be just a container locally. So it's just another option. And when we are talking about tools, like, do you have an experience with OPA, or do you see it working for audit as well, or it's more long-term solution?
I think that I know that at Citrix we use OPA. So our security team uses it for security auditing without help from DevOps team. And I know that OPA is currently actively developing because of there are a lot of security issues around Kubernetes pod security policies and its deprecation. So I think we will see more like more features and more interesting stuff from OPA itself. Maybe it will be easy. It can be easily adopted soon by developers or by DevOps team. But personally, I haven't touched this tool yet.
Cool. Thanks a lot. Any other questions?
I have a bit experience with conf test. It's a kind of tool based on OPA used for testing not even Kubernetes, but almost everything. if it can be written in YAML, JSON, HCL, and some other stuff, it can be used with OPA language, not OPA language, Rega language, and conf test to check it if it valid, if it complies with your security, or even your just checking your YAMLs to be correct. So it's really great.
Yeah, I also like it quite a lot. I still have some ways to improve, I guess, over time. Still early phase. Cool. Any other questions or comments?
And thank you for a great talk.
Yeah, thank you again for attending this meetup. Have a nice next presentation. Bye.
Okay, thanks a lot. Okay, so Jan, we can hand over to you and you can share your screen.
I hope that everybody can hear me now. Hello, everybody. I will just try sharing my screen as well. And if everybody can see my whole screen right now, I will be happy to start. Today, I would like to speak a bit about how we have implemented review apps in Kubernetes in DeepNode. I'm Jan Šťastný. Hello again. And you can always contact me at my deepnode.com email address, and I'll be happy to talk to you. And first of all, thank you very much for having us here on this meetup. First time for us, and hopefully not the last time. To start with, as opposed to Citrix, everybody probably knows who Citrix is. I will spend one slide or so talking about what DeepNode is, because it is possible, however unlikely, that you may have never heard of DeepNode. DeepNode is a tool that we are building. We are building a better data science notebook, as opposed to open source or local environments such as Jupyter Notebook that you may have heard of. We are fully managed. We are still Jupyter compatible, and we are collaborative. A few words on what notebook actually is, because this is not so common in the DevOps world. It is way more common in the data science world and in their ecosystem, as opposed to traditional programming where you write the code and you usually run it from the top to the bottom or from the beginning to the end. Notebook is organized into cells. You can see a couple of the cells on the screenshot here. Some of them are code, some of them are documentation. The code is very commonly repeatedly executed and fine-tuned out of order. So you don't always have to run the whole thing from the top to the bottom. This is very common for the data scientists, because they want to do some exploration. They want to fine-tune the different pieces of their explorations, and they want to also document it at the same time. And what we are doing is that we are making this cloud ready, and we are making it collaborative, same as you are used to working in Google Docs. A bit more boring part is the part about me. I have joined DeepNode about a year ago. I mostly work as a backend or infrastructure engineer, you could say, but we are a small startup at the time, although growing quite rapidly. So all of us do everything needed. And as for me coming to this meetup, which is supposed to be for the DevOps, I'm coming originally mostly from the dev part. I am a software engineer. I used to be an engineering manager building the software, but recently I have been quite a lot in touch with infrastructure, mostly because I like it and also because it's an important part of our product. So what are the for those who have never heard of review apps, it's a concept that we have not invented. We have stolen even the actual term from Heroku. I have used Heroku a couple of years ago in a different company where I used to work. And back then, they introduced something that they called review apps, and we found it very useful. The whole idea is that whenever you create a pull request in GitHub, your application gets deployed to a fresh environment. You get a fresh URL. Heroku does all of this for you magically, similar to how magically they deploy your application just based on your code. They do the same thing for the pull requests. You get a URL somewhere as a comment in the GitHub's pull request. You can open the application, you can do the review, you can test it, you can do some you can pass it to QA if necessary, and do everything you want to do with it before merging to develop or master and pushing on to some other stages like staging or production. This is helpful for both the author of the code and the reviewer. So far, I've only been describing the part where reviewer is interested, but later in this presentation, I will be talking a lot about how this can be beneficial even for the author of the code, the author of the pull request. So why did we want to have review apps in DeepNote? You could ask, like, hey, you could say your product is not at large, it's not hundreds of microservices, and your team is small, so you can only have a couple of environments and things like that. But when I joined DeepNote a bit more than a year ago, our Slack was quite full of messages like this. I'm taking staging for 30 minutes. I'm taking staging for a bit. Can I take staging? Is staging available? This was back in the times when we only had one staging environment. This was our full. We are running in Kubernetes, so this was as much close to production environment as possible. We are automatically deploying our develop branch on this environment. And time to time, somebody needed the full production Kubernetes configuration to test their stuff. And we really never wanted to, we don't have anybody, or we don't have the power or the space to spin up the cluster for every pull request or ask for a new environment. And we were always like, there are not that many of us. We can just share this one staging environment. And instead of deploying develop, time to time, we can say, hey, I will just test my branch on the staging. But this started becoming more and more of an issue and a bottleneck for the development. And I had previous very positive experience with using review apps and how beneficial this can be for everybody and the product going forward. And I was like, hey, why don't we introduce the review apps? Similar to how Heroku has it, and we are in Kubernetes, we can do this. The reason that another reason we want this or need this, and now I'm speaking for the author of the code, of the person writing the changes, is that some things are either very hard or impossible to develop locally, especially for DeepNote, which is built heavily on top of Kubernetes. We are currently running in AWS, and there are simply things that are difficult or impossible to do locally. As an example, whenever you run your code in deepnote.com, and anybody of you can do this is free to use, and you want to run your Python code in your notebook, we spin up a pod inside of the Kubernetes cluster. Pod is, for those less experienced with Kubernetes, pod is simply a running Docker container somewhere in the cloud. And this running a pod ad hoc locally requires you to have some sort of Kubernetes running locally. Not everybody was very happy about running Kubernetes locally, and it has never been very very easy to do so. We have done this. We used to have Minikube available for local development, but this was slow. This was never 100% compatible with our production or staging environment. So even though you wanted to test your changes on the infrastructure as it is in production, you could never actually really do this. The ingress is very different, and there were differences. This was due to this. This was also very difficult to keep up to date, because if we made some changes to the production cluster, we changed the kind of ingress we use and or other things, we always also had to somehow reflect it in the Minikube, because the configuration was slightly different. For all of these reasons, the adoption was very low, and not many developers actually used Minikube for local development. And then, even if we simply made people use this, there were parts that are almost impossible to run locally. Namely, in production, we use ZFS for the storage, and this is quite difficult to run locally on your MacBook, or very challenging at least. We are developers, so we did a very typical estimate of, hey, this is so easy, we can do this in 4 hours, and tomorrow we will be using review apps for our day-to-day development. So we went heads down into it. It has taken slightly more than 4 hours, I can already tell you that, but we succeeded, to give you some spoiler. And in the next section, I would like to talk a bit about the details of how we implemented the mechanism that we use really on daily basis. This is a very powerful tool of our developers, and we call them review apps because we have never found out a better name. We are building all of this on the fact that we are using Kubernetes, which makes it much easier for us. The fact that makes all of this easy is that all of the Kubernetes objects, such as deployment, ingresses, config maps, cron jobs, or whatever else you can think of, can be expressed by YAML, as an infrastructure as a code. And another important fact, or another important feature of Kubernetes that we used to build the review apps for ourselves in-house. We decided to do this as opposed to using an external service. We did a bit of research, but we concluded that building this in-house would be more efficient for us. We use the benefit of Kubernetes using namespaces. Most of the Kubernetes objects, such as those listed on the top, are scoped for a namespace. The namespaces can crosstalk only under certain circumstances, and they are nicely isolated. So the decision that we made was, hey, let's create a namespace for each review app. Let's reconfigure the application inside of the namespace a bit, and let's use this. The result was a script. We decided for Python, and the result is around 350 lines of Python that we have written in-house. It is integrated into our CI/CD pipeline. Namely, we use Circle CI. On the left, you can see one of the workflows that we have this is a typical workflow for a pull request inside of Circle CI. We have some tests running. We build all of the Docker images. Once we have the Docker images, we deploy the review application, which basically means running the Python 350 lines. As a result, if everything succeeds, and it does, I can tell you that, the Python script at the end adds a comment to the GitHub. Again, an idea that we kind of stole or we got inspired by Heroku. You get a comment from a deep node bot that gives you the URL where your application is, and it also gives you the date of the deployment, because if you commit more into your pull request, we need to redeploy. So this gives you an information about whether your review application is fresh or not. What are the insights of the deployment script? How does this work? What does it do? As I've already mentioned previously, we built all of this, or most of this, on the fact that Kubernetes is nicely organized into namespaces. So we create and annotate a namespace for each review application. The annotations are a feature of any object into Kubernetes. You can use labels and annotations to simply attach some metadata to your objects, to somehow organize them, to somehow categorize them, or whatever. We use our custom annotations for these namespaces, and the annotation that we attach to the namespaces that we use for review applications is the date when the review where the review application, or the namespace, you can say, was last deployed. The reason we do this is for us to be able to do the cleanup, because our cluster has to be, we cannot just simply grow it to the infinity. So we try to keep the number of the deployed review applications somehow low. After we have the namespace created and properly annotated, we copy the objects from the main namespace. The main namespace is the staging that we use to fight over. Here we benefit from the fact that everything in Kubernetes can be expressed by YAML. So we basically just pull the YAMLs from one namespace. We then transform it a bit. This is quite easy to do in Python. And after we transform it, we apply it into the namespace. And once we are happily done with everything, we attach the command to the GitHub. One could ask why that this could still be kind of limited level of isolation, because we are just creating namespaces inside of the same cluster. We have considered, but only very shortly, creating different clusters. But the fact that a cluster, or creating cluster, at least in AWS, takes easily 10 minutes is simply not something that we could wait for. We want this to be much faster than that. And also the costs would be much higher, and we would need more ingresses, we would need more load balancers and things that cost money. Whereas this deployment is way, way faster. As to the transformations that we do, which is the vast majority of the 350 lines of code, these are rather custom. We did not try to be too generic. We were trying to be rather pragmatic about this deployment script. So we, for example, know what kind of transformation we need to do on the specific ingresses and things like that. In my previous company, where we were in the situation of hundreds of microservices, we built a much more robust and much more generic mechanism to do this in Kubernetes. And it could be customized, and it could be extended and things like that. But hey, we are still startup. We don't want to spend too much time building a generic review app mechanism that will work for the hundreds of microservices that we currently don't have. We currently only have a couple, and we are completely fine writing custom couple lines of Python code just for them. We mostly change the tags or the names of the Docker images for our deployments and stateful sets. That's simply to get the fresh or the correct code running inside of the deployment or stateful set. We also quite heavily change the configuration values that we store in the secrets. And last but definitely not least, we changed the host names inside of the ingresses. We use Nginx as our ingress provider for Kubernetes. So the advantage is that the reconfiguration is basically immediate, and we don't need to wait for load balancers to reconfigure or things like that. One part that I've already touched is that we need to clean up all of these review apps, not to have hundreds and thousands and going forward infinity of the running namespaces. We do it exactly as I already mentioned, based on the annotations. So we have an hourly Circle CI job that checks through all of the review apps namespaces. It checks the timestamp or inside of the annotation of the namespace. If the review application is too old, it simply gets deleted. And also, in case there is no pull request open for the given review app, meaning that this pull request has already been closed, we also delete or shut down the review app. Simply to save the resources, or nobody actually needs this. Once this is in develop, once this is merged, nobody needs this. We, as I've already spoiled in the beginning, we succeeded. It took slightly more than 4 hours, but it was quite fast. We had it up and running in a couple of days. This was one of the last messages when I was taking staging to test the review apps. We successfully deployed this, and Jakub, who's our CEO, was also happy about this, and that's something that counts. But not only that, this is not what counts the most. What counts the most is that everybody on the team got massively used to review apps. Although people are definitely used to running the code locally when they develop it, they heavily rely on having the review app available so that they can test that all of the changes they have made work properly with our production configuration of the cluster, with our production configuration of the infrastructure. And this is not useful only for the reviewers, but also for the authors of the code. That's all that I wanted to very shortly talk about. I will be more than happy to go in depth in any of the aspects of either the mechanism we use or the kind of infrastructure we use, or in general, I will be more than happy to answer any questions. After we are done with the questions, I will say thank you right now so that I can stop sharing my screen and possibly see your voices and faces. If you start asking, there are links that you can get in touch with me. I will be happy to talk to you. And even as a follow-up, we can talk about how we use the infrastructure, how we use review apps or anything else. And the typical ending of this presentation should be, like every presentation of Meetup, is that we are hiring. So if you're interested by any of what I've just described, be it the notebook world, be it the data science, growing market, or just be it the infrastructure that we use, we will be happy to talk. Thank you very much, and I will be more than happy to answer any questions right now.
Thanks, Jan. Great presentation. There isn't any question in the chat so far, so just open it for anyone who wants to ask something now.
Are there any kind of shared resources like databases for the review apps, or you use
That's
one
an
database
awesome
for
question. Sorry, there was a lag. I definitely didn't want to jump into your sentence. Sorry about that.
Yeah, if you need to provision the database as well, or different resources for every review app.
We currently don't. There is one shared resource, or the most obvious one, and that's the one that you have just mentioned. We do share the database. We are still considering whether we change this or not, But for the 1 year of the history of the review apps, this has never actually been too much of a problem. So sharing a database does not seem to be that much of a challenge for us or a problem for us. So we just keep reusing the same instance of the database. We have considered using a database seed or an empty database or somehow seeded staging or things like that. But it has never actually become a priority because we don't feel the pain. But yeah, database is one of the shared resources, or the most obvious one.
Okay, thank you.
So there is a question in the chat now. So the question is, if you are using bare YAML deploys, and that's the reason why you need to mutate them with Python.
We like to deploy our production. We use Helm. We use Helm to describe our infrastructure, but we build on the fact that you can always, for object that you deploy in any of the ways, such as Helm or any other tool, you can always still ask Kubernetes to give you the raw YAML of the object, be it deployment, stateful set, or cron job. And we use this specifically for the review apps. So we basically use the Kubernetes API to ask for the YAMLs to be able to easily mutate it with Python, as you're very correctly mentioning in the chat, and then push it back. So the review apps are using slightly different deployment mechanism than compared to what we use for production. But again, this is something that we thought we would be pragmatic about, and so far it has been quite fine. Yes, we do need to make changes to the script time to time, but it's rather rare, so we are quite happy doing it this way for now.
By the way, previous speaker mentioned a Helm file. It's like it can help you a bit with destroying some lines in that Python code.
Thank you.
It's made especially for making your Helm deployed to something and for making it like review app, probably.
Mm-hmm. It was a very nice one. I have definitely put that down, and I have already put it to my bookmarks to look into later. So it was a valuable resource. Thanks for reminding it.
By the way, are you doing monitoring for all of this stuff?
Could you be a bit more specific? Like, what do you mean by monitoring? Like, which part?
Do you have monitoring for your apps? Can you check whether a new version is better than a previous one? Whether a new version uses more CPU memory or something like this?
We don't do this too much, honestly. We mostly use the review apps to test the actual changes in the code and the changes in the features or behavior of the application. At the same time, this is possible. Even the review apps are monitored. We use Loki for the logs, and we use Prometheus for the performance logging or for all of the activity logging. So this is possible, and you can, in case you want to pull the data about the performance of a review app, you can do that and create your own Grafana dashboard for this. At the same time, as I mentioned, this is not the primary use case for the review apps. We more often do this on the master staging instance just before going to production, because this honestly has never been too much of a challenge for us. And the reason I'm saying this is that the review apps, for cost-saving reasons, are slightly downsized as compared to either staging or even more compared to the production. So even if we did performance monitoring on the review app and try to compare it to something that is running either on the master staging instance or the production, the results could be slightly skewed by the fact that we are using slightly cheaper or smaller instances for the review apps.
Okay, thank you.
Okay, cool. So it doesn't seem like there are any other questions. If they are, then yeah, feel free to raise it up still. Otherwise, the recording is on YouTube if you want to watch it later or share it with anyone else. Hopefully the slides will be available in the meetup later on. We will really appreciate if you can give us some feedback, and the speakers as well. We'll share with them obviously after the session. It should take you just like a minute or two to fill up the SurveyMonkey. And yeah, thanks everyone for joining. If anyone wants to discuss anything else, feel free to stay on and talk. If not, then hopefully to see you next time. Thanks everyone.